Hello student, very good morning to all of you. What did we discuss yesterday? Yesterday we discussed about the design of that molecule, how it is designed. Generally, what we are going to talk today is a discovery, and in this we are talking about the concept of chiral templates and chirons, wherein the carbon skeleton is the chiral precursors. So in that point, according to our syllabus, what are the chiral template? What do you mean by the chiral template? What do you mean by the chirons? Where it is used in as a carbon skeleton, or how carbon frameworks are present? What are the chiral precursor? We talk lots on it in our previous lecture. So today let us see as far as this syllabus is concerned, or this chiron approach, and as I already told you why we are studying this, or what is the aim, or what is the purpose of studying this chiral, why it is necessary, why it is important one, where it is used. All these types of the question we are questions answer we are going to we are trying to find out in this course. So there generally so far we have seen in our previous design how to design that molecules. So by designing that molecule, there are purposely we are using for the natural synthetic, and the aim of this chiron approach to synthesize the target molecule, which are the natural product, and natural product are the most of are the drugs are what we can call it is a medicinally useful, and that's why we have to they are naturally present, but how we can synthesize that target that type of the natural product actually in our ordinary laboratories or in the research laboratories, how the scientists are trying to synthesize that type of the compound, why they are why they are using as a chiron approach, what is its perspective to study or to see the approach toward the chiron. So that are the thing, and mainly, and we know that there are 4 basic concept or basic natural compound are present in the organic compound. Generally carbohydrates, alpha amino acids, or we can call it as a amino acid, hydroxy acid, and the terpenes. By using these basic precursors means what? They are the starting material. By using this starting material, or by using this precursor, how we can build, how we can synthesize the target molecule that we are generally trying to find out here, or trying to study this. So there we are using as a term chiral templates are there. What kind of the chiral template? Carbohydrate is known as a chiral templates, and before that there is a chiron, and chiron is a word is generally coming, or it is a combination of the 2 words. One is they are coming from the retrosynthetic analysis. We are going to use as a retrosynthetic analysis approach, but via or through chiron approach. We are not going to go anywhere. We have to go by or go via chiron approach, because in the general retrosynthetic analysis is different than this one. We are reaching to the target molecule, which are we are reaching to the precursor, or what we can call it, reaching to the starting material, or the that are must be as a chiral, or chiral template means one type of, they must have a fixed pattern or the shape, they should have a pattern or particular shape, or there is a word is using as a chirality. Chirality means what? In a chemistry, a molecule or a ion is called as a chiral, and it is cannot be superimposed on its mirror image by any combination of the rotation and transformation, and this geometric property is called as a chirality, and that most of our drugs, or what we can call it as a medicinal compound, are chiral in nature. Chiral in nature means the chiral compound are the optically active. Optical activity is one of the property of the organic compound, means the certain substance rotate the plane of polarization through certain angle is known as optical activity, and the instrument used to determine or to measure the optical activity is known as a polarimeter. Polarimeter is the instrument used to determine that, and from that we can easily find out that. And chirality is an important concept for stereochemistry, because at the beginning we have seen how targets molecule and the precursor, what are the important feature they should have, because there is target molecule and precursor, they must have a chirality, and then precursor should have a chirality. In a precursor we can modify, but that type of the exact copy of the segment should be present in the chiral. And in the design we have learned there are the three type of specifically we have considered carbohydrate is a basic precursor generally used for most of the natural product synthesized by keeping the Chiron approach, or the basic precursor is a carbohydrate. And there are the three type of the carbohydrate type symmetries are present in the natural product. Number one is a carbohydrate symmetry. The carbohydrate type symmetry is apparent, means we can easily find out, or we can easily see that type of the skeleton carbon framework in a target molecule. Very easily we can recognize. In the second case, some of the natural product is that where the carbohydrate type symmetry are partially hidden over there, so you have to find out that one. And in the third designing of that we have learned designing strategy, we have learned the natural product we cannot find easily, the carbohydrate type symmetry is hidden over there, you have to arrive that one. So this type of the thing so far we have learned. So today we are going to start as a new point, that is a discovery wherein the carbon skeleton is the chiral precursor. Just now I have already told you the chiral and chirality about that. Chiral compound means what? The carbon atom carrying as a 4 different group is known as a chiral, and they are the optically active in nature, and it is one of the important property of that. And let us see here the chiral precursor. Precursor means it is a starting material, and that starting material, first one, because there are the mainly we are going to learn as a fourth chiral precursor. Number one is a carbohydrate, second one is a, I think, alpha amino acid. Alpha amino acid, they are used as a building block for the synthesis of protein and the nucleic acid. Then hydroxy acid, then terpene. These are the precursor we are going to how we are going to use those precursor in that discovery. We are going to find out how we can use as a carbohydrate can be used as a precursor for the synthesis of the natural product, which are drug or the medicinal compound. Now first one is a carbohydrates, right? First one is a carbohydrates, and as we know that carbohydrate is a separate study. There we will see the property of that, but here the carbohydrate means what? It is a polyhydroxy aldehyde or the ketone is known as a carbohydrate. That is the simplest definition. It containing as a carbonyl group, and there are the number of what we can call it the hydroxy groups are present over there. But in this section, as effort will be made to establish some simple guidelines in order to locate carbohydrate type symmetry in a given target molecule. Here specifically in the carbohydrates are there. In this section, what we are going to learn, what is the purpose behind it. In this section, an effort will be made to establish some of the simple guidelines in order to locate or in order to recognize the carbohydrate type symmetry in a given target molecule. And for a target molecule that contain, as we know that contain tetrahydrofuran and tetrahydropyran. These are the two rings always associated with these carbohydrates of lactone units. And for relatively simple cyclic molecules, simple acyclic molecules, the Chiron as well as starting carbohydrate template, we know that template, I think in the in the middle we already seen what type of the thing is called as a target molecule. Middle one is a Chiron, and then next one is a Chiron template with the pictorial thing we have seen target molecule, and then from that is a Chiron, and Chiron template nothing but as a chiral precursor, or what we can call it as a starting material, right? And template derivative may be evident and will not be discussed. And in other cases in which cyclic or acyclic, as we know that carbohydrate present in a cyclic form, two cycles are there. One is a 5-membered ring, another one is a 6-membered ring, and one is a acyclic means open chain carbohydrate. If you think about as a specifically is a D-glucose structure, there you will see that one, right? And in other cases in which cyclic or acyclic unit in the target are not directly convergent with the carbohydrate type structure, hidden or partially hidden carbohydrate type symmetry, the connection may be a bit remote until certain parameters are considered. While arriving at the chiral precursor, we need to study certain parameter. What are those parameters? Let us see here. First one is a framework. Framework means what? Carbon framework. Perspective means approach, why we are using that approach. Shapes, and shapes, what type of the shapes they have, evident and disguised. These are the some parameter we are going to study here, and we have been accustomed to visualizing the carbohydrate molecule in terms of acyclic and cyclic, 5 and 6-membered ring structure. The natural substitution pattern consisting of, and as we know that a natural substituting pattern consists of hydroxyl group and occasionally, because always a carbohydrate always consisting as a hydroxyl group. Occasionally means sometimes there will be a amino group, or sometimes is a carboxyl function has precluded their consideration as a potential useful intermediate in organic synthesis. As we know that carbohydrate containing a lot of hydroxyl groups are there, and they act as a potential, so we can introduce or we can remove whenever we require. So that's the intermediate in the organic synthesis. The central synthetic uses in carbohydrate chemistry have involved mostly peripheral transformations, such as the introduction of amino deoxy means D means remove, oxy means oxygen, and occasionally carbon branching as dictated, for example, by the necessities of the antibiotic modification. And the carbohydrate framework are, however, be used as a flexible platform for a variety of carbon-carbon single bond and other bond forming reaction. And since hydroxyl group can be systematically replaced by other functionalities with stereo control, and as I already told you that stereo control or the stereochemistry playing as a very important role in this particular Chiron approach synthesis. And with such a added dimension, one can look at the carbohydrate structure as an assembly of functional groups and substituents on a carbon backbone, which can be used as a template and made to adapt the topology and the shape of many targets and segment derived therefrom. As a number of shapes not normally associated with carbohydrates structure, but nevertheless inherent in its feasible acyclic or cyclic modification are illustrated below. No other group of chiral compound can other the synthetic chemist the combined advantage of variable chain length, functionality and stereochemistry provided by carbohydrate. Let us see there. Some of the structures are given here, how they present that type of the segment in the here. Let us see here. These are the skeleton present here. Some of the structures are there. Here may be as a hydroxy. This type of the zigzag, what we can call it as this type of the bond clearly indicate that there is this is a chiral carbon atom, but whether that OH is above the plane or below the plane, that type of the thing is not assigned, not fixed in this case, and that's why it is written like this. So this is one of that type of the skeleton we can see in the carbohydrates, or we can see another type of the skeleton over here, 5 member. This is a 6 member ring where it may be as this one is a 5 member ring, and this I am darkening this or thickening this one. It clearly indicates that this type of the skeleton is present. Again, OH is not fixed their geometry, or that whether it is above the plane or below the plane, we don't know. That's why it is shown like this. Another maybe as a, here I am writing, this is a acyclic compound where we can get here CHO. This is a skeleton over here, skeleton of this carbohydrates, skeleton of this carbohydrate. Here just simply that hydrogen at OH we can attach over here, and there is a CHO. This type of the skeleton may appear there, or it may be sometime. These are clearly you can see in the natural product or in our target molecule, and sometime is a partially hidden type of the compound we can see over here. These are the some of the skeleton I am showing over here. So these are the skeleton may be present over there. These are the some of the skeleton I am writing over here. This type of the skeleton. Now somewhere, sometime it may be as a like this. So this type of the skeleton or the segment you will find in our target, in the target molecule, and some of the structure may be as a like this. This I am darking, or these are the structure you will find somewhere, or maybe as a this one, and this type of the structure you this type of the segment or the carbon framework you may find in the target molecule somewhere like this, or this type of the structure or segment you will find in the compound, or maybe some of the structure I am drawing above one here. Maybe this type of the structure skeleton you will find in that. So some are the, or this type of the structure you may find in the carbohydrate. These are the segment present in the carbohydrates, or sometime it may be like this type of the segment you may come across with these segments, or it may be like this type of the segment you will find there in the carbohydrate. These are the some of the skeletons are there. And pattern, look at the pattern and shape derived from the carbon framework of various target molecules, convergence with the formation of the carbohydrate. Starting material is nothing but as a template. So this is the first point we have seen. Second one, locating the carbohydrate portion. Second one is the important one, locating the carbohydrate. First point we have seen this type of the thing, and second one is a locating carbohydrate portion, that is a bond disconnection or strategic bonds. So that is the second point we are going to discuss over here. What is that one? So that second point will be here. We are discussing second point in that carbohydrate itself. Locating the carbohydrate portion. Locating the carbohydrate portion, that particular portion, that is a bond disconnection strategy. Bond disconnection strategic bonds. So that is one of the important which bond to bring. Don't break the bond randomly. We must have to bond break in such a way that we can arrive to the chiral, and after that there must be as a chiral template, means we should reach to the starting material, and starting material should be keep in mind that is a carbohydrate, and as we know that carbohydrate skeleton so far. And for a given a target in which the carbohydrate types symmetry is hidden or partially hidden, there may be one or more ways to disconnect bond and derive suitable chirons. So in this case, some of the cases, suppose as a carbohydrate type of symmetry is hidden or partially hidden, at that time you require to break or disconnect the bond in one more than one way, so to reach to the starting compound or the chiral precursor, that you have to keep in mind. And while there are no general rules and the choice remains entirely arbitrary, the following guidelines may facilitate the task. There is no general rule, but scientists have given us some of the guidelines so that we can walk on that way, since the chiron is derived from chiron is derived from retrosynthesis reasoning, it is important that the reverse process be a practical and reasonable one. Since the chiron, and as we know that chiron, this is the word actually made from the two terms. One is which is coming from the retrosynthetic analysis, retrosynthesis, and as we know that in the retrosynthesis, that retrosynthesis is different, and this retrosynthesis, the finally you have to keep in mind, we are using as a chiron approach, means your starting material should contain as a chiral center, and then you have to think on according to that. Since the chiron is derived from the retrosynthetic reasoning, it is an important, and as we know that retrosynthesis an imaginary but logical reverse chemical process to reach the reactant starting from the target molecule is known as a retrosynthesis, or in other words it is known as it is a art of planning the synthesis of target molecule is known as a retrosynthesis. It is a reverse chemical reaction, right? And that reaction should be practical and the reasonable one. It should have, otherwise we cannot. When breaking the bond, you must keep in mind, you should have the bond making reaction, named reaction in your mind, then and then you have to break that bond. So that is a practical or the reasonable thing over there. And now in that first one, the hydroxyaldehyde or ketone connection, first one we are going to learn. Among these, first one that is a you can call it as a is one of the important one, the hydroxyaldehyde or the ketone connection. I think by locating this, let us stop today here. Remaining we will see next time is tomorrow, how the hydroxyaldehyde or the ketone connection or the what do you mean by the rule of 5, that we will see in next lecture. Let us stop today here. Thank you. Have a nice day.